paper. Now that day we did up to this point, right? Up to this question. Now you didn't do the paper, right?
No, sir.
Yeah. So we did up to 2D, and right now I'm doing 2E, and I'm recording the session, right? So you just follow from here, and we'll have a another session to cover what you missed. Now we finished the first question, and we did up to 2D. Now it is 2E, which is the binary search as a recursion function. You can see 9 marks given. So this is how it goes. So this is the array list. The prerequisite for binary search is the array has to be sorted in ascending order or descending order. So it's already sorted. So let's write the function. First, you watch, right? Then I will give you the chance. Def binary search. Okay, so if this is going to be a recursive function, right here we ask for the search value. For this function, we need to pass few parameters. Now, if you look at the normal binary search, it was not a function, so there were no parameters or anything. Now here we need to pass a few parameters. First, we need to pass the array, this array. So I'm going to have a parameter called ARR. Then we need to pass, so constantly, you know, this is going to, binary search is going to, now, I mean, in this one, this iterative binary search, you know that we constantly calculate the middle value, the mid. So here, when you're calling the function is going to call itself. Function will call itself and, you know, do it, call it again and again, go to the base case, and then do the recursive unwind, and ultimately give out the result. So if you think of this like a let's say a separate machine or something which does the binary search, we need to pass the ingredients, which are parameters. So I need to pass the array. Okay, this is the array. Use this array, find, do the binary search and find the value. Okay, then constantly it needs to calculate the mid value. So I need to pass the left pointer, left, which is initially going to be okay. Here, of course, we have used high and low earlier. So here, no, here also we'll use high and low. Otherwise, it. So this is the low value. Low value means the 0th index. This one, 0, and the high value is the last index, which is 9. Right. So we need to pass the high and low both. That is not enough because we are going to find the value. We are going to check whether a value is there. So we need to pass the search value as well. So I'm going to call it SV, search value, right? So these 4 parameters have to be passed. What are they? The array, we need to give the lower index and the higher index, and the search value. Why do you need to give the lower index and the higher index? Because it needs to calculate the mid value throughout. Understand? Is that clear? Is that clear?
Yes.
Okay. Right. Okay. So we need to, right now, this whole thing, this recursion should work only if the high value is greater than the low value. That means the highest index, which is this one, should be always greater than low. Right? At one point, this will come down to the lower index and then go beyond that, and then we should stop. We should tell the user, okay, the value was not found, right? So this whole thing should continue only if right, right is high here, high, which is the higher index, is greater than or equal to the low index, this one, low value, right? If it goes below that, we should say like, okay, we have checked the whole list, value was not found. Okay, so if this is true only, the recursion would happen. Else, right? Else means this high index, this one, has come down, and gone below this 0, which means we have checked the whole list. So if it is else, we need to return -1, which means we haven't found the value. Okay, as long as this is true, what should we do? We should calculate the mid. Always we should calculate the mid. So mid equals, how did we calculate the mid? You can see we added the high and low and took the integer division or the floor division of 2. Right, so I'm going to use the same thing. Mid calculation. Okay. Then in binary search, we are always checking whether the mid is our search value. Right, that is the only check that happens in the binary search. Right, first what we do is we find the mid, and then we check whether our search value is the mid. If not, we check whether our search value is on the left side or the right side. If it is on the left side, we discard the right side, including the mid. If it is on the right side, we discard the left side, including the mid. So the list is getting reduced and reduced half by half every time when we calculate the mid. So the next is to check whether the mid is our search value. If what's the array? ARR is the array. And we are looking at the mid value of the array, whether it equals to search value. What is the search value? SV. Okay, shall we call it search val or something? Search val. Here it is search value, and here the parameter is search val. You can use the same name also. Doesn't matter, as long as it's a variable, it's fine. Right. If this is true, we have found the value that we are searching for. So we are going to return the mid. Return the mid. So mid is not the value actually, it is the place where the value is, where our search value is. Or else we can return value found or something. We'll customize it later. Elif. Okay, now there are two conditions, right? If not this, if the search value is not the mid, then either our search value should be on the right side or the left side. So let's check whether it is on the right. So the next condition is we are checking whether our search value is on the let's say on the left side, right? So search val is less than mid, array mid. What does that mean? If the mid is let's say somewhere here, our search value is on the left side. Search value is less than the middle value. Okay, let's see how we checked it here. Mid is okay, we took the other way. It's fine. So if search value is lesser than the middle value. Okay, if it is true, we are going to call the binary search again. That's what happens in recursion. In the iterative, of course, we just update the mid and go back to the while loop and continue. But in recursion, what happens is there's no while loop in this. So if this is true, we are going to call the binary search again, but with some updated values. Right. So let's call binary search. So this is where the function calls itself. This function calls the same function itself. Binary search. Okay, now what are the updated values? What are the updated values? Okay. Again, we need to pass the array, right? We need to pass the array. Am I right?
Yes, sir.
Yeah, we are looking for the value, right? So we need to give him the array again. So it is ARR. Again, we have to pass the low value, right? Now, if it is on the left side, is it the low which changes or the high which changes? Low is here, high is here initially. Let's say our middle is this one. If our search value is on the left side of the mid, which point is going to change? Is it the low pointer or the high pointer?
Low.
Hey, low is here. Okay, let me show you like this. Okay, look at this. Right, our low is here. Our low is here. High is here. Let's assume that our mid is this. Okay, let's find the mid. By the way, it is 0 plus high is going to be 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 0 plus 9 is 9. 9 divided by 2 is 4.5. But we take the integer division. That's why it's double /. So the integer division is 4. So fourth index is the middle, which is 0, 1, 2, 3, 4. Okay, here's the middle. Initial round, right? Okay, now middle is not the value we search. Okay, let's assume that we are looking for 10 and middle is not 10. So we go to this one. Is our search value, which is 10, less than the mid? Yes. Okay, now what should we do? We should discard from here. We should discard this whole list because we know that it is not there. So we discard the whole right, and we are going to take only this part as the new list. Okay, now tell me which pointer should be updated. Is it the low pointer or the high pointer? Or the left pointer or the right pointer?
Right.
Right pointer or the high pointer, right? So high pointer should all the way come to this one. Because when you are discarding, we are discarding the mid also. Because that was the first check, whether mid is our search value. If it is not, then why do we take mid also? So that means it's going to be mid minus 1. Left doesn't change, or the low doesn't change. So low I have to pass as it is. Remember, these arguments are taken in the same order. So if I am passing low as a second one, I have to pass low again as a second one. But the high is going to change. So high is not going to be high anymore. It's going to be the mid, which is this one, mid minus 1. Mid minus 1. High is going to be in this position. What is that position? Mid minus 1. Right? So mid minus 1. Search value doesn't change. So search val. Okay. Now, you can't just call this, right? Because we need to get the values returned. Okay. Therefore, we need to call it with return statement. With the return statement. If you don't put the return statement, the recursive unwind won't happen. What is recursive unwind? You know, the recursion has a general case where it goes down to the bottom and then it comes up. Right? When the function is called again and again, it keeps on calling until it goes to the bottom level.
Oh, okay.
19. So there's a base case and a general case, and there's a winding.
So like normal binary searches and all will we have, or just this stuff?
No, normal binary search is there. That is there here. Right. So if you don't put this return statement, what will happen is the unwind won't happen. Unwind means this goes down to the base level, and then it should come up. For that, of course, you need to go through the recursion section if you have missed. So base case is the, I mean the general case is the normal function call, and it goes down and stops at the base level. And then the previous calls are going to be executed. So that's why return statement should be here. So you return, then you call the binary search again with the parameters with updated values. So if this condition is true, only the updated value is mid -1. Why is it? Why? All right, 1 is a number, right? Okay. Else means the opposite of this. That means it is on the right side. If it is on the right side, the only value that is going to change is the low pointer, right? Low pointer. So this one won't change. So it's going to be high. Low pointer is going to change, and it's going to change to what? It's going to change to now, if it is on the right side, okay? Let me erase this and just a minute, I'm getting a call. Right, now assume that our mid is here. This one is our mid. Okay, let's say our search value is this one. This is our search value. Now, if our mid is not our search value, and if our search value is greater than the mid, then obviously we know that it's on the right side. So we can discard from here, including the mid, we can discard. So the high pointer doesn't change, or the right pointer doesn't change, only the left pointer changes. So the left pointer should come all the way next to the mid. That's here. So the low pointer or the left pointer is going to be mid +1, mid +1 right there. Okay. So this is going to be low +1 or mid +1. We have used, sorry, mid +1. Low is going to be mid +1, low or left. All right, that's it. Then let's see whether this would work. Okay. Right, now we have the array list. We have asked for the search value. What we have to do next? We need to call the function. This will be the first call, right? Once we call this, it will start running on its own. But why? Because of the recursion. It calls itself. After that, it calls itself. But first time we need to call it. Okay, so binary search. What are the parameters? We had to pass 4 parameters here to start. What are the 4 parameters? First one is the array list. So now I need to give this variable, array variable, as an argument, which will be taken by ARR. So that goes. So the first one goes to this one. Then I need to pass the pointers, right? The left and right pointers. So these were the initial values. So I'll copy this and paste into this. Right. So what are the values I need to pass? I need to pass the low, which will be taken by this low. So low and then followed by high, which will be taken by this high. And then I need to pass the search value, which will be taken by search value. Okay, so those are the 4 parameters, 4 arguments actually, that I need to pass. Okay, but there will be a small problem here. If I pass high, right? If I pass high, high is not going to be updated, right? Because the reason is the array always gets what? Smaller and smaller. If it is getting smaller and smaller, the number of values is going to be less. That means the high is going to change, right? Isn't it? Right? Initially, the high is 9, but if you are discarding the right or left, what is going to happen? When the list is getting smaller, the high is going to be less. Am I right? When the array is getting shorter and shorter, the highest index is going to be lesser, right?
Yes, sir.
Yeah. So here, of course, in the iterative binary search, we have this one. As long as low is less than high, it is always checked, right? Okay. And high is updated. See, high is updated throughout. But here, when we pass high as mid -1, it is not getting updated. It is just being passed as an argument. That's all. It is not an assignment like this. Therefore, we have to pass this high as the length of the array. As the length of the array, right? Now we can't send length of the array because if it is length, it will be 10. But you know the last index is 9. So what we can do is we can take the length of the array, right? Array list and -1. Okay, length of the array and -1. This can be passed as high. Understand? Sorry, there was a network breakdown. High. No, that won't be a problem. Right? That won't be a problem. Okay, because this is the first call. No? This is the first call. Anyway,
so we don't need to put an error message if the list is empty.
No need. We'll assume that the list is there because they have given the list.
That there's values in the
yeah, they have given the list, right? Okay, this is not really needed because, like, you know why? Because this is the first call, very first call. So here, anyway, we are passing the value as an argument. No? So I don't think that is really needed. So we'll put high there. High, I have set it to 9 initially. right? Then this will be returning the final result. Final result is going to be either -1 or mid. Mid will be the result if the value was found. -1 will be the result if the value was not found. If you have reached the, if you have checked the whole list. Now I need to check the result. Based on that, I need to put out a proper message. So if result equals, this time it's not going to be true, it's going to be -1. If the result is going to be -1, then we have to say element is not found. Right? Or we can check the other way. If result is not equal to -1, element is present in the array. Else, element is not present in the array. There we are checking -1. Right? But it's going to be either -1 or the mid value. If it is not -1, we can say it is there, the value is there. Okay, let's run it and see. Search value. We'll search for 50. Search well not defined. Search well is not defined. That's here. No? Oh, I have missed the H there. Okay. Element is present in the array. Okay, let's search for the first value, which is 3. Present in the array. Let's search for the last value, which is 89. Present in the array. Let's search for a value which is not there. Perfect. Got it? Understood? So we don't need to like get the array length and -1 for this, right? Right, it works because here it passes it as an argument, right? Okay, Akash?
Yes, sir.
Right, Akash, it's your turn now. Write it and test it. In the meantime, I'll explain the code as in comments.